Welcome friends. Today we are going to solve a sequence problem. It is more of a sequence and limit problem. As you people can see, it is given that the sequence is defined by a recurrence relation and the first term of the sequence is 0. And then we have to find this limit. Give yourself a try and then come back to see the solution. Okay, so let's start with recursion relation first. The recursion relation is given by very simply an plus 1 equals to an plus 4n plus 3. That means here if you know the nth term, then you can know the n plus 1 term too. That is n plus 1 term is completely dependent on the previous term. What we can do now, we can simply replace n by n minus 1. Let's see what happens. If you replace, then n plus 1 becomes simply n. This thing becomes a n minus 1. This thing becomes 4n minus 1 plus 3. Right. Now, let's say it is 1. Now, if you replace n by n minus 1 here, that is in 1, then it becomes a n minus 1 equals to a n minus 2 plus 4n minus 2 plus 3. Now, if we substitute the value of a n minus 1 in 1, we have a relation. And it follows something like this. Say a n equals to a n minus 2 plus 4 n minus 2 plus 4 n minus 1. And see, here is a 3 and here is a 3. So there are 2 3s. So 2 into 3. And we can make some little adjustments too. And we can take 4 common and make this little adjustments. So 2 into 3. Now, here we write an, that is the nth term, in terms of the n minus 2 term, right? Now, if we proceed with similar arguments and we want to move to the first term, then this thing becomes like this: a1 plus 4 n minus 1 plus n minus 2 plus 1 and n minus 1 into 3. See, when we write an in terms of an minus 2, that is 2 terms before, here is 2 into 3. Now we write an in terms of the first term, that is n minus 1 terms lesser. So here n minus 1 into 3. The as follows the pattern. Now the first term is 0. So 3 into n minus 1 plus, and now we have to calculate this sum. And this sum will be n into n minus 1 divided by 2. This 2 and this 4 cancels out and it results as 2. Now we can take common n minus 1, and if you take common, it simply becomes 3 plus 2 into n, 2n. Right. So here we also have a formula of an, and the formula is given by an equals to 2n plus 3 into n minus 1. So what is the difference between the previous formula and this formula? In the previous formula, we have to know the previous term, that is a n minus 1th term. to know the value of a n, and in this formula if you put the value of n, you will get the value of a n, that is the nth term of the sequence. So in this case we don't have to know the previous term. It is the main difference. So now let's move our attention to the problem, and we have to find this limit. See here a n is under the square root, so we have to make some adjustments, and here is something, that is some coefficients of n, say 4, 4 square, 4 to the power 10, 2, 2 square. So we also have to make some adjustments for these things too. So let's say the general coefficient is k, so we can write it as 2kn plus 3kn minus 1. Now what we have to do, we have to make it a square root. So take square root on both sides, and now if we take common n, so it follows like 2k plus 3 by n, and it follows like k minus 1 by n. So this n and n square, and root under n square is simply n, so this whole thing becomes 2k plus 3 by n into k minus 1 by n. Now if we make some adjustments, say like this, akn by n equals to this whole thing, that is 2k plus 3 by n into the k minus 1 by n. And now if we take limit on both sides, because we have to consider the case when limit n tends to infinity, and if we take the case limit n tends to infinity, see these two things, 3 by n it will vanish, and 1 by n it will also vanish, so these two things becomes 0. So we are left with only 2 under the square root, and there is a k and there is a k, so root under k square it will result as k, so root 2k. Now what is our main problem? Our main problem is something like this. Let me write it for you. Root n plus root a 4n plus root a 4 square n plus root a 4 10n, and there is the same thing almost, but in place of 4 we have to write 2, nothing more than that. So 2 square n plus dot 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 2 to the power 10n. Now we have to apply the previous result which we got. We can make a small adjustment like this, just a small thing, and I assure you that you people are quite friendly with this kind of adjustments. And we divide this whole thing by n, and the beside things also by n. This will not affect the limit, but what is our help in this case? If we write the whole things like this, so say the total sum, that is this thing, root n to up to this term, if we divide the total sum by n, so the first term is divided by n, the last term is divided by n, and the middle terms are also divided by n. and then look back to our this thing. If you change the value of k and take limits, the whole thing is same. So we just have to, here see, here the value of k is 1, here 4 square. So it is not a limit problem now, it becomes a more of a series problem. See, the value is root 2k, so if you apply the value, so root 2 into 1, as the value of k is 1, in this case root 2 into 4, as the value is 4, and with similar arguments we will proceed like this, 24 to the power 10. And similarly in here also, but here the value is 2, or in the power of 2. Now see, the root 2 is common everywhere, right? So root 2 is generally easily cancels out actually. So if root 2 cancels out, we are left with this thing, and it is nothing but a finite GP series, and we are quite adaptable with some of these things, right? So if you have to make a sum of these things, this whole thing sums up like 4 to the power 11 minus 1 divided by 4 minus 1, that is 3, and this whole thing sums up like 2 to the power 11 minus 1 divided by 2 minus 1, that is 1. So it doesn't matter. And now you can make some adjustments with this thing. You can write 4 to the power 11 minus 1 as 2 to the power 11 plus 1 and 2 to the power 11 minus 1. And now see, these two things simply cancels out. So we are left with nothing but 2 to the power 11 plus 1 by 3. Right, so this is our answer, main answer actually. If you find this video useful, then please do like, share, comment and subscribe, and do support us too.